All right, here's our problem. Find the inverse of this matrix, 2, 2, 2, 1, using Gauss Jordan. So what is this method? What is an inverse of a matrix first? Let's talk about that. The inverse of a matrix is, let's say we have a matrix, A, so let's say this equals A. The inverse of a matrix is indicated by A with a -1. Kind of like it's an exponent. It's not an exponent. This is just the notation they use to indicate inverse. So if you multiply A by -1, then you're going to get the identity matrix, which is like essentially saying the identity matrix is like 1. 1's in the diagonal, 0's here. If you increase the size of the identity matrix, you get the same little deal going on. So 1's on the diagonal and 0's everywhere else. That's the identity matrix. So depending on the size, you can have different ones. Identity matrix here is square. It has to be square. So not every matrix has an inverse. There are some matrices which do not have an inverse. You can't multiply them by something and get an I back. So that's just something to be aware of. Let's do the Gauss Jordan method. Let's explain that. So that method, essentially, you're going to be taking a matrix. You're going to be making an augmented matrix with the identity matrix. You're going to do various row operations on this matrix in order to get that matrix to be the identity matrix. And whatever matrix you have on this side, that is going to be your inverse matrix. If you can't get this to be the identity matrix, then there is no inverse. Okay? So that's the method we're going to be applying here. All right. So let's make an augmented matrix. We'll do right here. 2, 2, 2, 1. Oh, we're augmenting it. So let's draw a line. We're putting the identity matrix here. I'm just so trigger happy with that, I guess. Okay. So we have our augmented matrix. Now, the pattern of how to get this is you're first going to turn this 2 over here. You're going to turn that into a 1. Then you're going to do whatever operations here. And then if this number is not a 1, which ours is conveniently a 1, then we're going to turn that into a 1 by multiplication, and then we're going to get rid of this element here. So if it's a bigger matrix, you're going to have to do more work going down, getting the diagonal. So get your pivot to be a 1, which is the numbers that are on the diagonal. That's your pivots. Get your pivots to be a 1, and then change the ones all underneath it to be 0, and then the ones above it to be 0 after. So kind of working your way down. So diagonal down, diagonal up. That's essentially what you do. So let's start with our first one, which is this 2 here. We want that to be equal to a 1. So what do we have to do to this row to get it to equal 1? If you don't know, if you can't intuit it, or if the numbers are like a little confusing, if there's fractions there, you can write it out. So row 1 is 2 times some number equals 1. What is that number? Well, let's just do some algebra. Divided by 2, divided by 2. That cancels that out, and so we get x equals 1/2. All right? So that's what we're going to be doing here. And don't be embarrassed if you just don't know. It's fine. Some people are better at this. If you practice this more, then you'll get better. Yeah. All right, so we're going to take, let's write down what we're doing. We're going to take 1/2 row 1. So let's write the row that doesn't change. 2, 1, augment, line, 0, 1. The first row is going to change. So 1/2, 2 times 2 is 1. 2 times 1/2 is 1. 1 times 1/2 is 1/2. 0 times 1/2 is 0. All right, we got a 1 here. Now we're going to work our way down to take care of this 2. So now I have to figure out, what do we want? We want it to be equal to 0. Okay, what do we have? 2 plus 1 times something. Let's say x. So, or 1 times x, so it's just x. 1 plus 2 equals 0. How do we get this 2 away? Well, minus 2 from both sides. We get x equals 2. So that's the operation we're going to do. So let's write our operation. Operation is row 1 plus row 2. What times row 1? Well, -2. let's write down what doesn't change. First row does not change. We're changing row 2. Then we're going to do negative 2 times 1 plus 2, 0. Negative 2 times 1 plus 1 is negative 1. And now we have a 0. And negative 2 times 1 half. Negative 2 times 1 half plus 0 equals negative 1. So that's what we're going to put here. Yep, negative 2 times 0 plus 1 is just going to be 1. Alrighty. Now see, we used to have 1 here, but we do not anymore. So we need to get rid of that negative 1. So negative 1 times what equals 1? Negative 1 times negative 1 equals 1. So we're going to do negative 1 row 2 to get us our next matrix. All right, let's write the rows that don't change. First row does not change. 1, 1, 1 half, 0. Negative 1 times 0 is 0. Negative 1 times 1 is 1. Negative 1 times negative 1 is 1. I meant to say negative 1 here. Negative 1 times 1 is negative 1. Okie doke. Now that we got this one, now we need to get this one to be a 0. So how do we get that one to be a 0? Well, conveniently we have a 0 here, so we're not going to mess up this 1 there. So what we're going to do is figure out how to get rid of that. So I think it's negative 1, row 2, plus row 1. Alright, let's write the row that doesn't change. Bottom row does not change. Augment line, 0, 1, 1, negative 1. And then we're going to do negative 1 row 2. Negative 1 times 0 plus 1 is still 1. Negative 1 times 1 is negative 1 plus 1 is 0. Negative 1 times 1 is negative 1 plus 1 half. So negative 1 plus 1 half is negative 1 half. And last but not least, negative 1 times negative 1 is 1 plus 0 is 1. So, if my calculations are correct, then this should be the inverse right here. We got the identity matrix over here, so this should be A inverse. Let's write that down. A inverse equals negative 1 half 1, 1, negative 1. And let's check. Take a screenshot of the answer that I got from an online calculator. Boom. Correct. We are right. All right. Thank you. If you have any questions, just let me know.